Every year, millions of tons of industrial slag and ash are produced by heavy industries. Most people see them as useless byproducts.
But inside heavy industry recycling plants, these materials are treated very differently.
Slag from metallurgical processes and ash from industrial combustion systems. They are not garbage, they are untapped industrial resources. Through controlled recycling processes, slag and ash can be transformed into valuable materials. This is not waste disposal. This is the beginning of an industrial production process.
Inside the blast furnace, molten iron and slag separate into distinct layers. The slag is tapped from the upper notch.
Split screen comparison. Untreated industrial slag and ash on one side, recycled slag and ash products on the other. Clean industrial visuals.
The process begins with material identification. Different industrial byproducts require different treatment paths. Metallurgical slag, fly ash, and bottom ash are introduced into separate intake systems. Each material stream is analyzed for composition, size, and moisture. This step prevents cross-contamination and ensures process stability.
Cement additives, road base.
By separating materials at the start, the plant establishes control over the entire production flow.
The recycling pathways for slag and ash include metal recovery, the creation of cement additives, and utilization as road base material.
What enters the system as mixed industrial byproducts now becomes clearly defined industrial inputs. Once identified and separated, industrial slag and ash move into controlled transport systems. Enclosed conveyors and sealed transfer points prevent material loss and environmental exposure. Each material stream follows a dedicated route designed for its physical properties. This controlled handling maintains material consistency throughout the recycling process. Stable transport conditions are essential for downstream mechanical and chemical processing. At this stage, industrial slag and ash are no longer uncontrolled byproducts, but regulated industrial materials. The next stage focuses on physical separation. Here, valuable components begin to emerge. Magnetic and mechanical systems extract metal content from metallurgical slag. Recovered steel and iron are separated before the slag continues further processing. Removing metal at this stage improves efficiency and protects downstream equipment. Non-metallic slag and industrial ash are now free of recoverable metal. What remains is a cleaner, more consistent material base, ready for mechanical refinement. After metal recovery, non-metallic slag and industrial ash move into mechanical processing. Industrial crushers reduce slag into controlled particle sizes. Screening systems separate materials according to precise size specifications. Fly ash and bottom ash are mechanically refined to achieve consistent grading. This stage determines the physical form of each future industrial product. What leaves mechanical processing no longer looks like byproducts, but like engineered materials.
The crusher load is fluctuating more than expected.
Mill speed looks stable though. Let's maintain the current settings.
Mechanical processing defines shape. Stabilization defines performance. Thermal treatment removes excess moisture and stabilizes industrial ash. Chemical conditioning adjusts material properties for long-term industrial use.
Thermally and chemically treated industrial slag stored in designated silos, clearly labeled.
These processes ensure environmental safety and structural reliability.
only materials that meet strict specifications move forward in the production line. At this point, slag and ash are fully stabilized industrial materials. After stabilization, industrial slag and ash enter the final output stage of the process.
The chemical balance graph is showing a variance in reactor 3.
Acknowledged. Increasing the reaction time by 10 minutes.
The first product is industrial slag aggregate, engineered for construction applications. This material replaces natural aggregates in road foundations and infrastructure. The second product is cement-grade fly ash, processed to meet strict industry standards. Used in concrete production, it improves performance while reducing raw material use. The third product is processed bottom ash, prepared for civil engineering applications. It supports infrastructure projects while metals are recovered in parallel. Recovered steel and iron return directly to metallurgical production. 4 distinct industrial products emerge from a single integrated system.
This is not waste treatment. This is industrial material production from slag and ash.